This is problem number 9 in section 11.1, but let's assume that we don't know this is number 9 in section 11.1. Then we will read the problem. The General Social Survey pulled a sample of 1,048 adults in year 2010, asking them how many hours per week they spend on the internet. The sample mean was 9.79 with standard deviation 13.41. A second sample of 1,399 adults was taken in the year 2014. For this sample, the mean was 11.62 with standard deviation of 15.02. Assume these are simple random samples from populations of adults. Can you conclude that the mean number of hours per week spent on the internet increased between 2010 and 2014? Use alpha 0.05 level of significance. And then we have ABCD. You know, when you do the whole process, you automatically answer ABCD. So I notice that we have two groups. So we have one group that they take a sample in year of 2010 and the other group in year of 2014. But the more important is we need to pay attention to the question. So this is the question. Can you conclude that the mean number of hours per week spent on the internet increased between year 2010 and year 2014? So you know that in this question, this is not confidence interval, but they ask you for hypothesis testing. The word, can you conclude that? You know that is for hypothesis testing. And the keyword in this case is the mean. Okay, so this is 11.1 because we are having two groups, and the question they're talking about the mean. So we go back to the keyword in the formula. So the word difference means two groups, and the word means that we have. This is not match pairs because the sample size are different. So we're gonna use this formula for step number 3 to find the test statistic. And if we want the GeoGebra, we will use this GeoGebra. Okay, so I already have some step in here. So first of all, we need to write down the given information. So first of all, we have year of 2010. So we have N1 is 1048, X1 bar is 13.41, and S1 is 13.41. X1 bar is 9.79. N2 1399. X2 bar is 11.62 and S2 is 1502. Now they are the given information. Now in the question, if we consider 2010 is group number 1 and we have the mean, when we write the notation for the question, we use the population notation. So the population mean is mu. So we have mu1, this is year 2010, right? And mu2 is for year 2014. The word increase means in year 2014 is more. So like this, right? Okay. Increase, that means we have more people using the internet in later on. So 2014 is more than 2010. So we're gonna use that question. So this is the question, and we're gonna use that to input into the new. We always assume that they are equal sign, and opposite to the equal sign is less than. In this case, mu1 less than mu2. Opposite can be not equal to, greater than, or mu1 less than mu2. In this case, we will choose mu1 less than mu2, and we use the left tail. The alpha given is 0.05, and again, we will use the formula in in 11.1 for test statistic. So I copy the formula one more time. Before the formula, let's write down the sentence. So under the new, we assume that mu1 equal to mu2. So what it means is that if we subtract them, we will get 0. Okay, so basically under the new, we will have 0 in here. And now let's just put in x1 and x2. So we have 9.79 minus 11.62, and then 13.41 square Okay, so you can either use GeoGebra calculator or just simple calculator, scientific calculator, and you will get this answer. Now we do the p-value. So first of all, you will draw the normal shape, and you will use the student, because we have t in step number 3, then we should use t in step number 4 also. We said that we will use the left tail test in H1, right? So what do is you will input the test statistic, which is in step number 3, that is negative 3.14, and you will find p. So p-value, that means you will find p. And you will use the GeoGebra, you will get the answer is 0.0008. I tell you why. For the degree of freedom, because we are using the t table or student, the degree of freedom is n-1, and we would choose the smaller n. So the sample number 1, we have 1048 is smaller. So the degree of freedom we will use is 1047. For the critical value, you will input the alpha first, which is 0.05 here, so that you find the critical value. And you use the GeoGebra you will get, okay, so we use the GeoGebra. Okay, so we're gonna choose student, and then we put in 1047 we have in the left side, and we put in the alpha, which is the area 0.05. So we get the number is negative 1.65. Go back to the p-value. I will input inside negative the test statistic. So negative 3.14 0.17, and I got 0.008 as you saw. Okay, so if we look at the p-value, now compare the p-value 0.008 and the alpha is 0.05, so the alpha is bigger, the p is smaller. Just like chapter 9, we will reject the null. And for the other side, the negative 3.17 land on here, land on the shaded region. So we will reject. The shaded region is reject. Now we will make the conclusion. We go back to step 1 and step 5 to make the conclusion. But before we read the question one more time, let's write down what it means, okay? So first of all, let's look at the null. This is mean the means are the same, right? And then this is the means. This is mean increasing, okay? So it show the internet use increase between 2010 and 2014. Okay, because me one lesson, do you remember we have the question? It said that increase between 2010 and 2014. That's why we set up mu1 lesson mu2. Okay, so that's what it means. So now we go back to step number 5 and we said that reject the null. Okay, reject the null, what does it mean? It means you will cross out the null. So what do you have left is increase between 2010 2014 that you just show in your work, in your problem. Now you go to the question and it's asked you, can you conclude that the mean number of hours per week spent on the internet increased between year 2010 and 2014? So the question asking us about this, and we just proved that, right? So we will say yes, we can conclude that, and then copy down the whole sentence down. Okay. So we already answered from part A to part D with the manually work. To check with the GeoGebra. So before we do the GeoGebra, I want you to notice that the degree of freedom is easier for us to use n-1, but we actually have the degree of freedom formula in the book. In the book, they tell us it's fine for us to use n-1 for is easier. So the answer we got is approximately close, but not exactly like GeoGebra. So here is the GeoGebra that we should use. Remember, we will use t-test different of the mean. We use the left tail test. The mean we will have is 9.79. The standard deviation is 13.41. The n is 1048. The other one is 11.62. Standard deviation is 15.02. And the n is 1399. So you look at the degree of freedom, the third from the bottom, the third line from the bottom. You see that the number is different from us, but that's fine. We get very close from our manually work, very close to the GeoGebra work. So you see T, that is the step number 3, test statistic. So we got negative 3.17. Yes, and the P, the last line, is the p-value 0.0008.